If you would ask me about micro frontends like half a year ago, I would tell you that this is just a buzzword. This is nothing that you should care about. But then I switched projects. I joined new company, and I would like to show you how this approach to the front end and UI architecture helped me building this project. And to keep your attention, I will tell you how to use all the frameworks at once. Isn't it fun? I guess we should all end wars between React, Angular, and Vue. We will just use all of them in one project. And the micro frontends will make it possible. But first things first, my name is Jakub Holak. I work as a front developer at R&D department of NordCloud. And NordCloud is basically public cloud company. Everything about public cloud is NordCloud. We work with AWS. And my department is responsible of creating tools that help managing cloud and using cloud for our colleagues at company and for our clients easier. And this project that I mentioned is basically the place where client and our company meets and uses those R&D tools. But before I will go to the definition of micro frontends, I would like to gently introduce you the problem that we are facing or that we will face in a short time. So the complexity of the front end application grows fast. So 15 years ago, there was just plain HTML generated by some server code. We used JavaScript basically for some minor visual effects. There were like 99% of business logic happened on the server side and the rest in the browser. But then Gmail happened, Ajax happened, and actually our personal computers, our mobile devices, our browsers became more efficient. So we started doing more logic in the browser on the client side. First, we were using this MVC model, so everything was one big piece of an app. It was AngularJS, it was Backbone, it was Knockout, and so on and so far. And then React happened and popularized the component-based model. So we are creating components, but still those components are tightly coupled within our applications. So we have state management tools that are coupling those components together to provide single app. And this, in my opinion, we are somewhere here. So it's fine for now, for most of the applications, but the complexity still grows, and possibly we will have to find another way to structure the architecture of our applications in the near future. And our colleagues at the backend side faced this problem some time ago. So they realized that their code is often just a like piece of the rock, like one solid big stone that is hard to maintain. Of course, they had this separation of concerns. So in big code bases, they had view layer, they had logic layer, they had data layer, but still they were tightly coupled. And as the apps became more complex, the productivity decreased because tight coupling inside these monolith applications turned out to be the problem. Because if you changed something in one feature, you could break 3 other features and don't even know about it. So they came up with this solution called Microservices. And Microservices is basically about splitting your application into smaller applications that are standalone, that are independent of each other, but and they are communicating, and each feature, each app is responsible for single business feature. So for now, they just vertically splitted the part, the feature logic and the data. So each microservice is one feature that connects logic and the data. But often, and this is like the most popular architecture today, the view layer is still like monolith. It may be single page application, or it may be server-side rendered. It doesn't matter. It still, every time you create some feature on the backend, the feature X team creates the feature, and then they need to wait for front end team to like cover this feature on the user interface. So I think this would be great if we can split the whole app into vertical features. Every feature is one team, so one team is responsible for everything, for front end, for back end, and for data. But how can we achieve it? It sounds cool because I will talk about benefits in a moment, but let's say we can ship all the features entirely independently. It sounds like something that we should go to. And how can we do this? The micro frontend term is just using microservices approach on the front end. As a developers, we are particularly good about agreeing on definition of things. So I will not try to define micro frontends. I will just quote this microfrontends.org. And basically, micro frontends is the way to think about your website, your user interface, as composition of features that are independent and owned by teams that has their own like area of business logic to care about. In other words, let's just split our user interface into separate self-contained applications that are independent and that communicates as less as possible. So let's say we have some job offers website, and it has this this kind of wireframe. Of course, this is like really high level, but I just want you to show the idea, to see the idea. So basically, we have this job offers. This is main component of our site, and we have these widgets provided by other teams. So job offers is provided by job offers teams. A team, they are responsible for creating it from A to Z. So they are managing the data, the logic, and they provide us the user interface. Search team provides us with the widgets for searching, and so on and so far. So basically, every time the user team changes something in their like logic, they can reflect it right away in user widget, and the widget is updated. They don't need to wait for any other team to catch up. So benefits of this approach, first of all, increased productivity, because we can ship features faster. I think this is self-explanatory. So another thing that is really important, it's minimizing the tech debt, because every feature can be created with new stack. So updating the stack of micro application is easier than updating the stack of big monolith app. Another thing is increased autonomy of the development teams, because they can deploy and work at their own pace. This is very important, but more of that, they can choose tech stack that they like, and they don't need to watch for other teams and like discuss the tech stack of the whole application with them. Another thing is avoiding tech stack lock-in. I bet there are people here that started working on some big application 5 years ago, and they said, whoa, let's use AngularJS because this is the coolest technology for now. And they are still working on this AngularJS. So all the cool kids are using React styled components and all the stuff. And they are locked in with this Angular behemoth, let's say. And if we decide to split our user interface into micro apps, there will no longer be this will no longer be the problem, because even if you use some legacy framework, it will be just responsible for the part of the UI, and new features can be created with new frameworks. Another thing, I guess this is the last benefit that I am mentioning on the slides, is progressive rewrites of big code bases, and it's kind of connected to this AngularJS behemoth, because when you have this big AngularJS application, you would like to rewrite it to React because you can't find developers that want to work with legacy technology. You want to update to the newest, coolest framework because of reasons. And to do that, you would need to go to your boss and tell, hey, our team will not work on any new features. We'll just fix in critical bugs for next year because I want to rewrite it to React or something similar. Business will not be happy about it. But if we decide to use micro frontends, we can just take the edge functionality, create micro frontends, mount it to the old monolith, and step by step, rewriting each feature to micro frontends, you will end up with this old monolith as one of microservices because it will be small enough. So this is the theory, the benefits, and so on and so far. But what about like real implementation? So there is no single tech stack. Like there's no framework or library or some piece of code that you can use and then say, hey, I'm using micro frontends. This is more like an idea of how to structure your application. And I guess composing user interfaces from separate applications is popular among a lot of companies, but not a lot of them are like talking openly about it. Few examples. Zalando uses Project Mosaic, and Project Mosaic is just a set of open source libraries. Basically what it does, every team creates so-called fragment, and fragment are merged together to create website on the server side. You should check the Project Mosaic via Google. They have a bunch of libraries, really cool stuff. Next thing, Spotify claims to have this Stitch framework, so-called. This is not open source, unfortunately, but they say that Spotify application is actually built from separate views, and they are all the views are just put in iframes, and the iframes communicate with each other using this Stitch framework. And another example that you can find online is Allegro. Allegro uses so-called OP box. They described it on their tech blog, and basically what it is, it's the collection of components and definition of how the components should be combined on the user side and where should they look for the data to fill in the components. So yeah, this is something that you should check. I don't want to talk more about those examples because I don't work on them. Another approach, it's single SPA. Single SPA is so-called meta framework that allows you to run applications made with different frameworks side by side in the browser. So this is definitely worth checking. And another approach, the approach that I like the most, is based on web components. It's proposed on this microfrontends.org that I mentioned before. So I hope you all know the idea of web components. Just to introduce the core technology that is used here. Custom elements are just HTML text connected with the logic described by the class that you defined while defining custom elements. So basically we can create our tag and tell the browser where is the class that describes the behavior of the tag. And using this web components, we would end up with something like that. Every team will just give you a web component with the logic, with the user interface, the logic, the way to get the data from the server. We'll just give you the web component, and you will just mount it and use it as the part of your site. And actually, from the user, from like consumer of this web components, you will just use it this way. This would be the whole HTML file. Of course, you will pass some data, but each web component will be used like video tag or other complicated tag. So yeah, this is the approach provided by microfrontends.org, and I think it's really interesting and maybe really useful in the future. And finally, approach that I've taken at Nord Cloud. So basically, the project that I am working on is the user interface for a bunch of different projects that has nothing in common. They are done in our department, but that's all. And I wanted each team to provide their own user interface. And I created only the so-called UI shell. It's just router. So every time router and some basic layout, header, footer, and the sidebar. So each time user comes to my website, and ask for some route. For example, invoicing route. I check the configuration, ask the URL provided in configuration to give me a piece of JavaScript. This JavaScript generates web component, and then I am using web component as the page that you are currently on. So this is like something in between the Stitch framework, where you have each view is each app, and this usage of web components. So some details. We have small shell app responsible for providing user context, because each app and each web component needs to know what user uses it. And then we have this amplify library that is just set of methods to work with AWS resources in the browser. And I am passing it to each application so that we have just single amplify that is used by every sub-application. Then every route is a sub-app. Every sub-app can provide its own sub-routes. So we have this main router, but each sub-app can have its own router and show the details about something or something like that. It depends on them. If they decide that there is nothing to show on sub-route, they will just go to 404 page. And each sub-app is just JavaScript file that is exposing a web component factory. That's all. So this is the router setup. So we have some views built in our shell. So homepage to be available right away is provided in the shells. Same for user page and 404 error. And there is the sub-app component. And basically, what it does, it just checks the setup, checks if in the setup there is a route that matches the route that was provided by router. And if so, it takes this load script from URL, gets the URL, and the URL is responsible, as I said, for providing factory with init method, and we just pass it the amplify, we pass it the DOM string that we want to use as a tag, and it uses React custom element library. This is just very simple library that mounts React application to custom elements. So we have web component, and in the web component we basically have whole React application. And that's all. So every team is responsible for providing this sub-app, and we are just opening sub-app based on routes. There is a question: is it worth to use micro frontends? And it depends, because the same as with microservices, it depends on scale. If you have small application, the monolith is just fine, because with micro frontends, as with microservices, comes the initial cost of creating the shell, of creating the contract between the shell and the micro applications that you are using. You need to provide some method of communicating between micro frontends. The same is with microservices. So this chart, this is actually for microservices created by Martin Fowler, and if you want to get more information about micro frontends, this site is very helpful. So basically, at the beginning, when the complexity of your application is small, the productivity is better for monolith applications, because the architecture of microservices is more complex and so on and so forth. But when the complexity of your application grows, microservices and micro frontends start to shine, because each time you work with the code of your feature, you work with just a small part, and you can be sure that if you change and it works, you don't break anything else in your application. So some final thoughts from battleground with micro frontends. First of all, if you decide to like use micro frontends or use like separate apps in your monolith, avoid shared state. If you want to use Redux or any other state management, every application should have its own store. And if you want to like exchange information between micro frontends, just use events and let your application react to the event. Shared state is bad here. Create shared UI elements library, and this is very important because we want every team to use the same components so that this final product that we are providing to our user is cohesive, and the feeling is like this is one solid app. They don't need to know that it's done by separate teams and so on and so far. Another thing, measure performance, because if you encapsulate the framework, the state library, and all other things in every micro frontend apps, you can end up with providing like 2 megabytes of JavaScript code to solve something that could be solved in 100 kilobytes if you use monolith. So you need to be aware of that every micro app should be independent, so they shouldn't share any dependencies. So if you want to use React, even if it's the same version, each web app should provide its own React and it should be encapsulated. And the last thing, you may not need a framework, because we all love frameworks, but if you provide micro frontends that are small enough, vanilla.js may be something that will work for you, because there is the area that you are the area of responsibility for each micro apps will be really small, and the complexity as well. So that's all about micro frontends for now. Thank you.
Kuba, I don't know if you know, but apparently your talk was so controversial. We have more questions than from the rest of the speakers combined.
Whoa, that's fine.
Someone was actually trying to drop table questions. It didn't work, luckily. I have a feeling that you answered some of those questions, especially in the last few slides, but maybe someone was
actually the plan, because I hoped for
a
lot of questions.
There's lots of them, so I know after party is cancelled, we're going to stay here. In any case, how do you avoid repeating yourself using micro apps? As in, how do you avoid reinventing the wheel in this part of the application and this one and so forth?
Actually, sometimes you can't avoid it, because there are separate teams, so you share knowledge. You need to create libraries of components, and for example, visual components is just one example, but if one company invents some clever way to do something, it can be published in your company's GitHub and then installed as dependency in both micro apps. So you need to share knowledge between teams, but again, the code within each app will need to be encapsulated. So sometimes two apps will be doing the same.
Okay.
This is like the cost of microservices, I believe.
Yeah, and there were also a couple of questions. I'm trying to combine several questions into one. There were questions about performance and bundle size if you don't end up shipping 10 different copies of React to the users.
Yeah, this is the problem that I consider the biggest one, because if you want to use React, and we are front-end developers, we love frameworks, although sometimes it's like we don't need it, because if you just do a simple widget for search bar, you may be fine with just vanilla JavaScript or some smaller library. I created this approach of compiling all the React applications with Preact, actually. Okay. So we have really small bundles, and this is some kind of resolution for that. I think you should consider if you need to think about bundle size like heavily, because some applications don't need it, like internal application, like
intranet is slow anyway. So
yeah, Exactly. So it is a problem. I don't have one solution, but using less frameworks, using smaller frameworks is kind of response for that.
There were also questions about styling, but I have a feeling that you answered this one to create.
Yeah, just create a big library, and if all teams using the same framework, it can even be a library of CSS in JS components. But if not, you can create like bootstrap-like template for your company, and then every team will just be obliged to use it.
Okay, and there's also a couple of questions about state, because you did mention that if you have, for instance, different React/Redux application, each one of them should have a separate state. But for instance, there are things that probably most of the app should be aware of. For instance, if the user is logged in or not, and how do you handle that?
We handle it this way, that we have this small, let's say it's not based on Redux, state object, and each time the state object changes, we emit the event, and each microservices is like obliged to react to those events. If you need user context, for example, and user changes because, I don't know, he edited in one micro application, he edited his name, and then so we emit event, and each application should react to the event, and then just change their state accordingly. Okay,
so basically you, kind of create a global event, and then each part of the application handle it differently. There are also questions about teams, as in how do you introduce a new developer to a stack which basically can have different frameworks?
Yeah, but the thing is that one developer should work on one microservice at a time, let's say micro frontend at a time. It depends how you name it. So the problem just doesn't exist. Of course, I don't encourage you to use all the frameworks and use Vue in one microservice and React another, and Angular in third one. This is not the case, but if the problem occurs, I believe the problem won't occur because the team and the application will be so big that there will be no like jumping between microservices. I believe each team has just front-end developer responsible. Of course, it's like ideal world, but there is no ideal world, and for some teams there will be like they will need to choose one framework and create all the microservices in one framework, but it's nothing bad because they can ship and deploy at their own pace, and this is like the core, not the framework part. This was part of a joke.
The last question I want to ask you before we go on a coffee break, I mean, there's no silver bullet, so are there any drawbacks to this approach? Like, if you wouldn't recommend microservices for some kind of application, so what kind of
I guess I wouldn't recommend micro frontends for or MVP applications and or startups and so on so far, because the initial cost is big, especially that we don't have like silver bullet technology that, as I said, like framework or something that you use, and you have micro frontends. All the shell or the contract between shell and micro apps will need to be established, and it will cost a lot. So I would suggest this approach of creating MVP as a monolith, and then when it works, just slice out the parts of the application to the micro frontends, mount them back to the monolith, and if you continue to do that, at some point you will realize that the monolith is so small that it's just another micro frontend. So
basically avoid over-engineering from the start.
Yeah.
Okay, and to the remaining 200 of you who also ask questions, I'm sure you can find Kuba during the break.
I will hang around, so if you want to kill me.
And also at the after party. So we're going to have a break now. Thank you very much, Kuba, for your talk.